Hi friends, welcome back to our channel Physics Tutorial. Today we are going to discuss some previously asked questions of CBSE grade 12 physics. Can we move to the question? This question is asked in the year 2018. This is a 3-mark question. The question is 3-point charges Q, minus 4Q and 2Q are placed at the vertices of an equilateral triangle ABC of side L as shown in the figure. Obtain the expression for the magnitude of the resultant electric force acting on the charge Q. And also the second question is there, that is, find out the amount of work done to separate the charges at infinite distance. So here we have two questions. So the first one is having 2 marks and the second one is having 1 mark. Okay, so what is given in the question? So here a diagram is given and 3 charges we can see here, 3-point charges, that is Q, then minus 4Q and 2Q charges. They are placed at the vertices of equilateral triangles, this ABC. Okay, and each side is having length L. And now we have to find the expression for the electric force acting on the charge Q. Okay, so first of all, how we can answer that question? So total force acting on the charge Q we have to find. So the charge Q is kept at A. So here there are 3 charges, right? So for finding the total force on the charge Q, we have to find the force on the charge Q due to this minus 4Q charge and also due to plus 2Q charge. Okay, so then we will get 2 equations of that forces F1 and F2, and then the resultant we have to find by using parallelogram law of vector addition. So we can find the values of F1 and F2. So force on the charge Q due to charge minus 4Q, that can be taken as F1. Okay, so that is vector F1, that is equal to 1 by 4 pi epsilon 0. How we can find? Q1 Q2 by R square. So here instead of Q1 Q2 we have minus 4Q and plus Q. Okay, and L square. So length is L. So instead of R square we can use L square. So how we can write F1? F1 is equal to 1 by 4 pi epsilon 0 4Q square by L square. Okay, so that is the equation for finding force F1, and that will be along AB. Here we have kept a minus charge, so that will be negative charge, means that the direction will be along AB. And now we have to find the force on the charge due to 2Q charge. So how we can find that? F2 is equal to 1 by 4 pi epsilon 0 2Q square by L square. Okay, so that also will be along CA. Here we have positive charge, so that will be along CA. Okay, so that will repel. And here the total force, that means here we can see that the forces F1 and F2 which are inclined at an angle 120 degree. So that we can see in the next diagram. So how we can find the resultant? By using parallelogram law of vector addition. So here we know F is equal to root of A square plus B square plus 2AB cos theta. Okay, that is the general equation for finding the sum of the 2 vectors, right? So here how we can write? F is equal to root of F1 square plus F2 square plus 2 F1 F2 cos theta, and here we have told that the angle theta is equal to 120 degrees, so that also we can apply here. So that will be equal to root of F1 square plus F2 square plus 2 F1 F2 cos 120. Now in the diagram we can see the directions of forces F1 and F2. Okay, and the angle between them is theta, that is 120 degree, and then we can write the value of cos 120 also. So we will get it as root of F1 square plus F2 square minus F1 F2. Now we can apply the equation, that is 1 by 4 pi epsilon 0 Q square by L square can be taken outside, and that will be equal to root of 16 plus 4 minus 8. Okay, so that values of F1 and F2 that we have to find. So the equation we are getting as 1 by 4 pi epsilon 0 2 into root of 3 Q square by L square. So that is the final answer, that is the total force acting on the charge Q due to these 2 charges, that is minus 4Q and plus 2Q. So that is the first question, and we have one more question to answer. Now the second question was to find out the amount of work done to separate the charges at infinite distance. So the amount of work done means here we have to find the potential energy of the system. So here we have a 3 charge system, then how we can find the potential energy of the system? That is U will be equal to U12 plus U23 plus U13, or we can say that U is equal to 1 by 4 pi epsilon 0, then Q1 Q2 by R12 plus Q2 Q3 by R23 plus Q1 Q3 by R13. That equation we have already discussed, right? It is the potential energy of a system of 3 charges, right? So that equation we have to apply here. So what we will get? Net potential of the system. So that will be equal to 1 by 4 pi epsilon 0 Q square by L, that is constant, right? Within bracket we can write Q1 Q2, that is minus 4. Okay, so plus then Q2 Q3, so that is 2 plus minus 8. So the total equation we are getting as minus 10 by 4 pi epsilon 0 Q square by L, or that work done is equal to 10 Q square by 4 pi epsilon 0 into L. That can be written as, yes, that 5 and that 10 and 4 will get cancelled. So we can write it as 5 Q square by 2 pi epsilon 0 into L. Okay, so that is the work done or the potential energy of charges of a 3 charge system. So for this question we are getting 1 mark, and for the previous question 2 marks. So total 3 mark we are getting for the question. Now we have a 5 mark question. That question is asked in the year 2020, and that question is from ray optics. Okay, so I will read the question. 2 thin lenses are placed coaxially in contact and obtain the expression for the focal length of this combination in terms of the focal lengths of the 2 lenses. So first question is, here 2 lenses, thin lenses are given and they are in contact. Okay, and here we have to find the expression for the total focal length of the combination. That is, here we have to find the focal length of the combination of lenses. Okay, and the second question is, a converging lens of refractive index 1.5 has a power of 10 diopter, but when it is completely immersed in a liquid, it behaves as a diverging lens of focal length 50 centimeter. Find the refractive index of the liquid. So the second question is a converging lens, that means a convex lens which has a refractive index of 1.5 and the power is 10 diopter, and when it is completely immersed in a liquid, what happens? It behaves like a diverging lens, that means just like a concave lens, and which has a focal length of 50 centimeter. Now we have to find the refractive index of the liquid. So that is the second question. So we can answer it one by one. In the first question, we have to find the focal length of the combination of these 2 lenses. So for that, we have to consider 2 convex lenses, that is very thin lenses we have to consider, and lenses can be taken as L1 and L2, and their focal lengths are F1 and F2. Okay, so here we have 2 lenses and the object we have to place at O, and they are placed coaxially in contact. Okay, so that the points, that means the optical centers, will be coinciding. So we can assume like that. So if it coincides means we can see a point P at which the optical centers are coinciding here. And now suppose we place the object at O, and if L2 is absent, suppose only L1 is here, then what will happen? Where the image will be formed? Suppose only one lens is there, means this is a converging lens, so that on the other side the image will be formed. Okay, so here we can see that I1 with the dotted lines we have drawn I1. So I1 is the image formed due to this first lens, that is L1. Clear? So the distance between the object and lens, that is O and L1, that can be taken as U, that is the object distance, and the image distance of the first lens, Okay, so that will be L1 into L1I1. That can be taken as V1. So that is the image distance for the first lens. So in that case, we assume that L2 is absent. But if we place L2 there, what will happen? This image, that means I1, that will act as the object for the second lens. So we can say that this V1 is the object distance for second lens also. Clear? And here what we have to do is, here if we place only one lens, what will happen? We can use that lens equation for finding the focal length, right? But here we have two lenses, so separately we have to find the equations for L1 and L2, and then we can add it together to get the focal length of the combination. So first of all, we can find the equation for the first lens for L1. How we can write the equation? Actually, we have studied that if only one lens was there, means the equation will be 1 by V minus 1 by U is equal to 1 by F. That is lens maker's formula. 1 by V minus 1 by U is equal to 1 by F, right? So here V is the image distance, U is the object distance, and F is focal length. So here in the first case we can substitute that equation. So what we will get? The equation will be, here we have, yes, instead of V, instead of image distance, what we have here? 1 by V1. Okay, so 1 by V1 minus 1 by U, that will be equal to 1 by F1, because this is the first lens. So 1 by F1 we can write. Okay, so that is our first equation. Now what we have to do? We have to place that L2 also, and then what will happen? That I1 or V1 will be acting as the, yes, object for the second lens. So what will happen? The image will be a more clear image will be formed at I. Here in the diagram we can see that. Okay, so what will be the image? So image distance, where we can find here the distance between L2 and I. So that will be equal to, yes, V. So V is the final image. So that will be the image distance Pi. Okay, so that will be the final image formed, and here we can also use the equation, lens equation. So how we can write? 1 by V minus 1 by U is equal to 1 by F. So here which one is the image distance? Yes, that is V. So how we can write for the second lens? Yes, or the final image, 1 by V minus 1 by, yes, what is the object here? Here the first image is acting as the object for the second lens, right? So 1 by V1 will be in object distance. So object distance means here V1 we are taking as the object distance. So we can write 1 by V minus 1 by V1 is equal to 1 by F2. So that is our second equation. Now for getting the total focal length, what we have to do? We can add it together. So both the equations will be added. Then what we will get? 1 by V minus 1 by U, that will be equal to 1 by F1 plus 1 by F2. Okay, because the other equation that will get cancelled. 1 by V1 minus 1 by V1. So that will get cancelled. So the equation becomes 1 by V minus 1 by U is equal to 1 by F1 plus 1 by F2. And that combination can be replaced by a single lens of focal length F. Okay. So that the equation will become 1 by V minus 1 by U is equal to 1 by F. Now we can compare the equations 3 and 4. So what we are getting here, we have 1 by V minus 1 by U is equal to 1 by F, and 1 by V minus 1 by U is equal to 1 by F1 plus 1 by F2. So if LHS is same, we can equate the RHS also. So what we can write? 1 by F1 is equal to 1 by F1 plus 1 by F2 is equal to 1 by F. So that is the case of combination of lenses, that is the focal length of the combination of two lenses. Okay, so 1 by F1 plus 1 by F2 is equal to 1 by F. Clear? Now we can solve the second question. The question is, a converging lens of refractive index, that is 1.5, has a power of 10 diopter. So here the refractive index, that is N, is given as 1.5, and the power P is equal to 10 diopter. So here we can write minus 10 diopter, and when it is completely immersed in a liquid, what will happen? It behaves like a diverging lens which has a focal length of 50 centimeter. So focal length of the lens becomes F that means A is equal to, here by using that power equation we can find the focal length, right? So how we can write, power is equal to P is equal to 1 by F. So F will be equal to 1 by 10 here, right? So that will be equal to 0.1 meter or 10 centimeter. And in liquid what happens, the focal length is given as 50 centimeter, and that behaves as a diverging length. So here minus 50 centimeter we can write as the focal length. And now these are the things given here. Now what we have to find, the refractive index of the liquid we have to find. Okay, so by using these facts we have to find the refractive index of the liquid. So we can use lens maker's formula. So how we can apply? So what is lens maker's formula? Yes, that is 1 by F is equal to N2 by N1 minus 1 into 1 by R1 minus 1 by R2. Okay, so here we can substitute the values. That is, F air is given as 10. Okay, and N2 and N1 are given, so that values also we can substitute. So what we will get, 1 by 10, that is equal to, N2 is the refractive index, that is 1.5 is already given here. Okay, refractive index of the medium of lens, so that is 1.5 divided by N1, that is equal to 1, that will minus 1, that into 1 by R1 minus 1 by R2. And here if we calculate, what we will get, 1.5 by 1 minus 1 is there, no? So that will be 0.5, then into 1 by R1 minus 1 by R2. So we can give this as the first equation. So this is our first equation, 1 by 10 is equal to 0.5 into 1 by R1 minus 1 by R2. This is the case of air. Okay, now suppose that lens we have immersed in a liquid, then the same equation we can apply. So in the case of liquid, what happens, the 1 by F means 1 by F of liquid we have to write, then N2 by N1 minus 1 into 1 by R1 minus 1 by R2. The same equation we are using here also. So we can substitute the values. Here F liquid is equal to minus 50. Okay, we have already told that it will act as a diverging lens of focal length 50 centimeter. So here 1 by minus 50, that is equal to 1.5 by N1. N1 we don't know, so that minus 1 into 1 by R1 minus 1 by R2. So N1 we have to calculate. Okay. Now we have two equations. So if we divide these two equations, what we will get here, 1 by 10 in LHS we are doing now. So 1 by 10 divided by 1 by 50 minus 1 by 50, right? So that will be equal to 0.5 divided by 1.5 by N1 minus 1. So this rest of the term will get cancelled. 1 by R1 minus 1 by R2 will get cancelled. Okay, then we can calculate this value. Then what we will get, 1.5 by N1 minus 1, that is equal to 1 by 10. Right, then if we rearrange this to get N1, what we are getting, N1 is equal to 1.36. So that is the refractive index of the liquid medium. Okay, so here we have to find the refractive index of the liquid medium, that we are calculating as 1.36. So the lens maker's formula we are using to find that. So that you have to remember, this type of questions may be asked for exam. Okay, so here we have to remember the equation, that is 1 by F is equal to N2 by N1 minus 1 into 1 by R1 minus 1 by R2. That is very important equation. So hope it is clear to you. Now we have another 3-mark question which is asked in the year 2017. The question is, a ray of light incident on face AB of an equatorial glass prism shows minimum deviation of 30 degree. Calculate the speed of light through the prism. So here what is given, a ray of light is incidenting on the face AB. So here we have an equilateral glass prism, and through the face AB the light is incidenting, and here which shows the minimum deviation of 30 degree. Okay, we have to calculate the speed of light through the prism. And one more question is there, that is, find the angle of incidence at the face AB so that the emergent ray grazes along the face AC. Okay, so first of all we can start with the first question. In the first case, what are the things given here? Here the angle of minimum deviation is given, that is delta M or D, that is 30 degree. And here we know that this is an equilateral prism, that is that is why the angle of the prism will be 60 degree, right? And what we have to calculate, the speed of light through the prism we have to find. So here we can use the equation, that is mu or n, that is refractive index is equal to C by V. Okay, so from that we can find V. V will be equal to C by mu. So how we can find mu or the refractive index of the prism? Yes, for that we can use the equation mu is equal to sin A plus delta m by 2 by sin A by 2, or we can use the another symbols also, or n is equal to sin A plus d by 2 by sin A by 2. So the same equation that we can use here. So if we substitute the value of minimum deviation, what we will get? Sine 60 plus 30 by 2 divided by sine 60 by 2, right? So sine 60 plus 30 by 2 by sine 60 by 2 we are getting. So that value is calculated as root 2. So here refractive index of the prism is root 2. Now what we have to calculate here? The speed of light through the prism that we have to find. So how we can find the speed? That is mu is equal to C by V. So that equation can be used here. So C is equal to velocity of light. So 3 into 10 raised to 8 divided by root 2. So that B is equal to 3 into 10 raised to 8 by root 2. So that will be equal to 2.122 into 10 raised to 8 meter per second. So that is the speed of light through the prism. So for the second question, we have to find the angle of incidence at the face AB so that the emergent ray grazes along the face AC. So a condition is given that is the emergent ray is just grazing along the face AC. That means at that face the angle will be 90 degree. Okay, that means the angle of emergence will be 90 degree. And here we have to find the angle of incidence. So the diagram is shown here. The angle of emergence we can see here, that is along AC the ray is grazing, so that the angle will be 90 degree here. And here we have R1 and R2, that is the angle of refraction is given here. So how we can find the angle of incidence? That is the question. So here E is equal to 90 degree, and here we know that the refractive index, that is mu is equal to 1 by sine R2. Okay, and mu we have already calculated as root 2. So from that how we can find R2? R2 will be equal to sine inverse of 1 by root 2. Okay, that is sine inverse of 1 by mu. So that will be equal to 41 by sine inverse 1 by root 2 is 45, right? So that R2 we are getting as 45. And now we have from the diagram R1 plus R2 is equal to A. Okay, that is the angle of equal to the angle of the prism, and angle of the prism is equal to 60 degree. So R1 can be written as A minus R2. So that is 60 minus R2 we have already calculated, that is 45. So that will be 15 degree. Okay, and we have the now we have to find angle of incidence. Let angle of incidence be I. Okay, so angle of incidence means the angle between the angle of incidence and normal. Here it is marked. Okay, the normal and angle of incidence. So in between the angle I is coming, and that we have to find. So here we have another equation, mu is equal to sin I by sin R. Okay, so how we can find that sin I from that? Here mu will be equal to root 2, and that will be equal to sin I by sin 15. Sin R we have calculated now, right? So that can be substituted here. So I will be equal to sin inverse root 2 into sin 15. So that value will be equal to angle of incidence. So like that we can calculate the value of angle of incidence. Okay. So hope it is clear to you. Now we can conclude the video. If you like the video, please like, share and subscribe. Thanks for watching.